1-8, an introduction to equations. So our objective for this lesson is to solve equations using non-algebraic methods. So that means we're going to use tables, we're going to use mental math, we're going to use a little bit of logic, we're going to do a lot of stuff. Solving equations algebraically is the entire next chapter. So we'll look at all of those different strategies in chapter 2. But for now, we wanted just a quick introduction, just a little practice with solving equations without using any algebra. Okay. So our essential understanding is that we can use an equation to represent the relationship between two quantities that have the same value. Okay. So let's do a little warm up here with our solve it or getting ready problem. An animal shelter has a fundraising goal of $7,500. The diagram shows the result for the first 3 weeks. The first amount is negative due to upfront costs. When would the shelter reach its goal? Make an estimate, state any assumptions, and justify your reasoning. Well, we can see that we're going to start at negative 500. Week 2, we have $500. And week 3, we have $1,500. So it's pretty clear that we're going up by $1,000 each time. All right, so if we wanted to try to make an equation, we can clearly see that because we're going up by $1,000 per week, that my equation for the amount of money that I have is going to be $1,000 times the number of weeks. But that's not where if I plugged 1 into W, I didn't start at $1,000. Okay, so I need to subtract by the $500 for my upfront costs. Okay, so if I think about let's just make a table. Week 4 would be $2,500. Week 5, $3,500. 6, 45, 7, 55. Need some more room. 8, 65. And week 9, we would finally have our $7,500 if this pattern continued. And that's sort of how we're going to think about these. It would have been a little easier to just solve that equation, right? Switch the amount of money that I want for $7,500. And we can solve that equation, and we'll talk about that in chapter 2. But for now, we're going to stick with a little bit of logic. So the problem in the solve it can be modeled by an equation. An equation is a mathematical sentence that uses an equal sign. That's all it is. Okay? So we're just going to make some sort of sentence, some sort of statement that has an equal sign in it, and then that is an equation. An equation is true if the expressions on either side of the equal sign are equal, like 1 plus 1 is equal to 2, or x plus x is equal to 2x. Both of those equations are true because both stuff on either side of the equal signs is actually equal to each other. An equation is false if the expression on either side of the equal signs are not equal. Like 1 plus 1 is equal to 3, x plus x is equal to 3x. Neither one of those are true. An equation is an open sentence if it contains one or more variables and could be true or false depending on the values of the variable. So let's look at our first problem. Let's classify these as true, false, or open. Well, part A, 24 plus 18 is 42. 22 plus 20 is also 42. So this is true. Hopefully everybody knows that 7 times 8 is 56, and that is not equal to 54, right? If we have an equal with a slash through it, well, let's make that a little bit better. If we have an equal with a nice slash through it, then that actually means not equal to. So this is false. And if we look at part C, that could be true when x is the right number, but this is open because there is a variable. So as soon as we see this variable in my equation, I know that it is going to be an open statement depending on the value of the variable. Okay? Let's try our got it problems. True, false, or open. So the first one, you can actually see that it has a variable. So that is open. 16 minus 7, is that equal to 4 plus 5? 9? Well, that is 9 is equal to 9. So that is true. And 32 divided by 8 is 4, whereas 2 times 3 is 6, so that is false. Okay? So next, the solution to an equation containing a variable is a value of the variable that makes the equation actually true. So if we want to figure this out, we can do it with a little substitution. Is x equal to 6 a solution of the equation 32 is equal to 2x plus 12? Well, I know what I want x to be. There's my variable. Just plug it in. 2 times 6 plus 12. So usually when we solve things, we like to work down, follow order of operations. So that's going to be 2 times 6, which is 12 plus 12. Multiplication comes first. Now we do addition, and 32 is not equal to 24. So is x equals 6 a solution? So the answer to this question is no, it is not. It is not a solution. Let's try a got it problem. Is m equal to 1/2 the solution of the equation 6m minus 8 is equal to -5? So let's plug in m and find out. So that's 6 times 1/2 minus 8 is equal to -5. So remember how to multiply fractions. So it would be 6 over 2, which is 3, minus 8 equal -5. And that is actually true. So the answer to this is yes, it is a solution. Okay. Is there any other value for m that would make this equation true? And the answer to that is no. 1/2 is the only one where you can get the one side equal to the other side. And that's not always the case. There's some equations that we'll look at that have more than one solution, but in this case, there's only one. So in real world problems, the word is can indicate equality. You can represent some real world situations using an equation. So here we go. An art student wants to make a model of the Mayan Great Ball Court at Chichen Itza, Mexico. The length of the court is 2.4 times its width. And we can see that the length is 54 inches. The length of the student model is 54 inches. What should the width of the model be? Well, okay, we'll get to how to solve this in the next chapter, but for now, we can just use a little bit of logic. First, we're going to set up the equation, and then we're going to try to figure out which one of these answers is actually correct. So, my equation says the length is 2.4 times the width. So the length is 54. So I can say 54 is going to be equal to 2.4 times the width. Now I just have to figure out which one of these answers is actually correct. So I would do 2.4 times the first answer, 2.4, and see what I would get. Plugging that into my calculator, I get 5.76. That's not 54, right? That's not equal to 54, right? So that one, not equal to 54. Let's try B. So that's going to be 2.4 times 11.25. Plugging that into my calculator, I get 27, which again is not equal to 54. Okay? For C, we have 2.4 times 22.5. When I plug that into my calculator, I get 54, which is what I want. And then I can actually check the last one, but it's obviously going to be much too big. Plug that into my calculator, I get 311. Okay? So the answer is going to be C. And again, we could have solved this with with our algebraic tools, but we want to practice a little bit of logic. And in this case, a technique that is called back solving, which is where we use our answers and plug them back into the question and see which one of those works. A very useful test taking technique if you have a multiple choice question. Okay? Let's look at another problem. Our got it problem. The length of the ball court at La Venta is 14 times the height of its walls. Write an equation that can be used to find the height of a model that has a length of 49 centimeters. Okay, so I have pretty much all the information I need, and I want 49, the height to be, the length to be 14 times the height. So it's going to be 14 times some height. And you might notice that there is no number that I can multiply 14 by to give me 49. 49 is not divisible by 14. So we're going to get a fraction, but that's okay. Usually that's what happens. Okay, so problem 4, we're going to now use mental math. Okay, so we can ask ourselves, what's the solution of each equation? We can ask ourselves, what can I, if I have something and I want to add 8 to it, and my answer is 12, what is that something? Well, I can just think and say, well, if I started with 4 and added 8 to 4, I get 12. Okay. And again, for part B, something divided by 8 is equal to 9. What is that something? Well, how about 72 divided by 8 is 9? Okay. And then, of course, as we get to the next chapter, we'll see that 8 times 9 is 72, which is how we would actually solve this problem. So for our got it problem, same idea. What is the solution of 12 minus y is equal to 3? So you got to ask yourself, what, if I started with 12 and I subtract something from it, what is that answer? And it is 9, right? Because 12 minus 9 is going to be equal to 3. So the answer would be 9. Okay? So another way we can solve an equation without using an algebraic method is to make a table. So I'm trying to find the solution of 5n plus 8 is equal to 48. Okay? So we can start with guessing some value of n. I can then plug it into my equation, 5n plus 8, and then I would get my answer. Okay? This is not the most efficient method, but let's try it and see what happens. Let's start with 0. If I plug 0 in for n, it turns into 5 times 0 plus 8. 5 times 0 is 0, plus 8 is 8. It's not 48. Okay, let's jump up. Let's try 5. 5 times 5 plus 8. That's 25 plus 8 is going to be 33. Close, but not quite. Let's try 6. 5 times 6 plus 8. When I do this, now I get 38. And now I can kind of almost see a pattern going. If I plug in 7, 5 times 7 plus 8 gives me 43. And I'm really close, and I think it's going to be 8. And it will be, because that's 40 plus 8, which is 48. And I can kind of see my pattern here of each number going up by 5. Okay. Uh, Again, not the most efficient method, but helpful to recognize this pattern. We couldn't really tell the pattern from 0 to 5, okay? But as we started going up by one number each time, right, I can start to see my pattern over here, and that'll come in handy when I actually want to start making functions from data. Okay, let's look at this guided problems right here. What is the solution of 25 minus 3p is equal to 55? And we're going to use a table again. So let's get p. Let's get 25 minus 3p, and then my answer. Okay, and let's start by plugging in a 0. That's 25 minus 3 times 0, which is going to be 25. Well, watch what happens when I plug in a 1. We get 25. Oops. Let's move this out of the way for a second. We get 25 minus 3 times 1, which is going to be 22. So now my numbers are going down, but I want my answer to be 55. Okay? So if I went up by 1 and my answer went down, I would maybe have to go down by 1 from 0, like -1. 25 minus 3 times -1 gives me 25. -3 times -1 is a +3. So that's 25, 28. Now I'm going the right direction. And of course, if I plug in a number like -10, I would see that my answer becomes 55. Okay? So if you are trying to solve with this method, a little guess and check method or a table method, it is always good to notice the pattern, okay? And what was a good starting value to solve part A, right? We started with 0, we went to 1, we saw that didn't work, and we went the other direction. So 0 is not the best starting point because it doesn't really give us too much information and it wasn't really close. A better starting point would have been, well, -10 would have been the best starting point because then you would have your answer. But if it was just a guess, maybe -5, -7, something like that. Okay? And if you weren't sure, after you plugged in the first number, and you noticed that you were not getting closer to your answer, you definitely have to try to change tactics. Okay? So what's an estimate of this solution? Not the actual solution, just the estimate. Okay? So let's use a table. So that's -9 at, oh, whoops, sorry. Let's start with my input values, x. Okay? My equation is -9x minus 5. And I'm going to have my answer column over there. So let's start with 0. If I plug in 0, I get -9 times 0 minus 5, which is -5. Okay, not 28. If I plug in 1, I would see that my numbers would be getting smaller because I'm making this more negative. So I'm going to try to go the opposite direction. I'm going to plug in -1. So that turns in -1 times -9 times -1 minus 5 gives me an answer of 4. Okay, +9 minus 5. Okay, plug in -2, and I get -9 times -2, which is +18, minus 5 is 13. Plug in a -3, -9 minus 2, minus 5 times minus 2, no, sorry, times minus 3 gives me an answer of 22. And negative 4, negative 9 times negative 4 minus 5 gives me an answer of 30, gives me an answer of 31. So I know my answer is going to be somewhere in here, and it's going to be closer to the 31 than it is from either. Okay, so if we were to estimate this, it would probably be about negative 4, somewhere in between negative 3 and negative 4. Okay, and we'll look at how to get exact answers in chapter 2. Okay, so for this lesson, make sure you know how to determine if negative 9 is a solution to this equation. Just plug it in for y. To use mental math, to write an equation, write a basic equation for a problem. Give an example of an equation that's true, false, and open, right? Nice and easy. 2 plus 3 is equal to 5. That's true. 2 plus 3 is equal to 6. That's false. 2x plus 3 is equal to 7. That is open because it has the variable. Next one, pretty straightforward. Write an open equation using one variable in division. Could be anything. And use two different methods to find the solution of the equation. X plus 4 is 13. I would say use mental math because that's a pretty simple equation. Hopefully you see that it's 9. Using a table you could use, but that would maybe take too long. Okay, so some weird methods that we went through here, but the idea here is to introduce us to equations and how they work. In chapter 2, we'll talk a little bit about how to solve all of these algebraically. And that was 1-8, an introduction to equations.